Question 16. Use the graph to identify whether each of the following is a cycle, an open walk, an open trail, or a closed trail. In order to solve this question, you are going to need to remember your definitions. So if we have a look at our three main exploration definitions here, we have a walk, which is a route through a graph, a trail, which is a walk with no repeated edges, and a path, which is a walk with no repeated edges or vertices. Now, the only difference between open and closed is whether you start or finish at the same point. If you start and finish at different points, it's open. If you start and finish at the same point, it's closed. And you'll notice there's an order here too. If you have a look at a walk is just a walk. You're wandering around aimlessly. It has no rules about it. Whereas we get to a trail, it's still a walk, but we're not allowed to repeat any of the edges that we've crossed. And finally, a path is one step up from a trail in the sense that not only do you not repeat the edges, but you also don't repeat the vertices. Okay, so let's have a look at the question here. A, F, C, F, B. So if we just quickly draw them in, we start at A, go to F, go to C, oops, that's the wrong way, go to C, go back to F, and go to B. So we can see there that the edge between C and F has been repeated. So it's not a path and it's not a trail, and we didn't end up where we started. So we would call this an open walk. All right, B. Let me use a bit of a thinner pen here. So we start at A, we go over to F, to C, over to E, back to F, to B, to A. Okay, so let's start off right at the end, okay? Is it a path? Well, you would have noticed that we crossed vertex F twice, so it is not a path. Is it a trail? Well, looking at it, we didn't repeat any of our edges. So yes, it is a trail, and it also started and finished at point A, so we would say this is a closed trail. And finally, let's have a look at C. We start at A, go to B, to C, to D, to E, to F, and back to A. Notice how no edges or vertices were repeated, and we started and finished at vertex A, so we're going to call this a closed path, or a better name for it is a cycle. Question 17. Calculate the distance along the parallel of latitude between Mount Gambier, South Australia, which is given the coordinates of 37 degrees 50 minutes south, 140 degrees 47 minutes east, and Burnsdale, Victoria, which is 37 degrees 50 minutes south and 147 degrees 37 minutes east, to the nearest kilometre. Okay, in order to solve this question, you are going to need to go into your formula booklets and find yourself the formula for Earth geometry, where we're looking at distance. Now, you have two formulas here, and depending on the coordinates given to you will depend on which formula you will use. In this question, you will notice that our lines of latitude are the same. When your lines of latitude are the same, you are going to use the second formula, the one involving cos, and your lines of latitude, your coordinates for that are going to be input in for theta here. So using this, let's go ahead and solve the question. So D will be equal to 111.2 cos of 37 degrees 50 minutes times our angular distance. Now, our angular distance here will be our difference in longitude. So we will have 147 degrees and 37 minutes minus 140 degrees and 47 minutes. All right, so let's simplify that and put that into our calculator. I'm going to keep the first part as is, 111.2 cos of 37 degrees and 50 minutes. And I'm going to simplify my angular distance here. So let's have a quick look on our calculator. 147 degrees and 37 minutes minus 140 degrees and 47 minutes. Oops. 47 minutes will give us 6.8333. Now you could leave it there, or guys, if you want to keep it exact, let's change it to minutes and seconds. So we get 6 degrees and 50 minutes. All right, inputting all this information into our calculator then. So 111.2 times cos of 37 degrees and 50 minutes. Making sure you close your brackets here. Multiplied by our angular distance of 6 degrees and 50 minutes. Closing our brackets once again. Gives us a approximate distance of 600.14 kilometer. Now it's said to give the answer to the nearest kilometer, so we'll say the distance is approximately 600 kilometers. Question 18. Exhibition organizers believe that the number of attendees increases each day as an arithmetic sequence. The organizers know that 353 people attended the first day and 439 people attended the third day. Determine the common difference. Okay, so looking at this question, straight away it says we have a arithmetic sequence. So I'm going to go to my formula booklet. I'm going to look up the formula for arithmetic sequence, and I'm going to use this to solve my question. So let's start writing down some information. We know that on the first day there were 353 people, and on the third day there were 439 people. So straight away we know that T1 is going to be equal to 353. And we also know that T3 will be equal to 439. So let's have a look at our formula here. Our formula states that Tn equals T1, our first term, plus n minus 1 d. Now we're trying to find what d, our common difference, is. So if I was to take the information I've got and substitute it into the formula, let's see what we get. So Tn, why don't we make that T3? So we know what our third term is. So we've got T3 is going to be equal to T1 plus n minus 1. Well, if we're using T3, this will be 3 minus 1, and that'll give me d. Okay, so let's do some substitutions now. 439 will equal 353 plus 2 times d. So let's bring up our calculator over the side here. So first of all, in order to get 2d by itself, we need to subtract 353 from both sides. 353, which gives us 86. So 86 equals 2d. And to get d by itself, we would divide 86 by 2, which will give us 43 equals d. Sorry, that's a bit messy. Let me fix that up. 43 equals d. So therefore, it's always good to write a sentence, guys. The common difference is 43. Okay, let's have a look at the next part of the question. Use the results from 18A to predict the number of people who will attend the 6th day. So this is using our rule again, which was Tn equals T1 plus N minus 1 D. Now we want to know how many people are going to attend the 6th day. So let's start filling in our information. We need to know T6. We already know T1, and T1 was 353. And we're going to add on N minus 1. Now, because we're looking for T6, N is 6. That means we're going to have 5. And we're going to multiply that by D, which was 43. And we're going to put this into our calculator and see what we get. So 353 plus 5 times 43, which gives us 568. So therefore, on the 6th day, 568 people will attend. Question 19. Data was collected relating the number of hours spent fishing and the total number of fish caught. The linear model for this data was found to be y equals 2.3x plus 31.4, where x is the number of hours spent fishing and y is the total number of fish caught. A. Use the model to predict the number of fish caught if 12 hours were spent fishing. Now we know the hours spent fishing was relatable to x, so when x is 12, y will be 2.3 times 12 plus 31.4. So let's put that into calculator and see what we get. 2.3 times 12, close our brackets, plus 31.4. We get a solution of 59. Now, because this question is only worth 1 mark, I wouldn't bother writing a sentence. Let's have a look at part B. The correlation coefficient for this data is 0.688, and the coefficient of determination is 0.473. Use each of these to describe the strength of the linear association between the two variables and decide if your prediction is valid. So let's have a look at the first part of this question. The correlation of coefficient and its value of 0.688. Hopefully you remember the correlation coefficient tells us our direction and our strength of our graph. Okay, and if we were to have a look at this little number line at the side here, when our correlation of coefficient is 0, it's like there's no correlation. As it gets closer to 1, it gets stronger, and as it gets closer to -1, it also gets stronger. So a correlation coefficient of 0.688, I would say it displays a moderate positive correlation. So let's put that in there. Now let's have a look at the next part. A coefficient of determination of 0.473. Now our coefficient of determination, guys, is our R squared value, where our correlation of coefficient was our R value. Now what our R squared value tells us is it tells us the percentage of variation in Y and how it can be explained by X. So in this scenario here, an R squared value of 0.473 suggests that approximately 47% of the variation in the number of fish caught, which is on our y-axis, can be explained by the amount of hours spent fishing, which was on our x-axis. And last but not least, we need to decide whether the prediction is valid. Well, if you have a look at that information, it's moderate, okay? So 0.688 is a moderate strength. That's kind of good. And an R squared value of 0.473, look, it's not too bad, but it all comes down to basically what else needs to be taken into consideration. So in conclusion, while possibly valid, other factors need to be taken into consideration. I don't think a value of 0.473 or 47% is incredibly strong, but it's not bad. Question 20. Determine the monthly repayment on a $350,000 home loan over 25 years with 6.5% fixed interest compounded monthly. Looking at this question, the key words that started off are monthly repayment. This right away tells me I need to use an annuity. Whenever we're making a payment or a investment that is a fixed sum at a fixed interval, we're dealing with annuities. Now, if you have a look at your formula booklet under finance, you will find the annuities formulas, of which there are two. Now, looking at these formulas, guys, the difference, and this is how I use them, by all means, everybody might have a different technique. This is just me. I look at the power of n, and this is how I remember them. If I am trying to grow a fund from 0 up to whatever I'm investing in my superannuation, then I would use the one where the power of n is positive. On the other hand, if I'm paying back a loan or I'm retired and I'm withdrawing from a fund, so there's already a set amount there and I'm trying to decrease that amount to 0, well, in that case, I would be looking at the power of negative n. All right, so in this scenario, I've borrowed money. In fact, I've borrowed $350,000 and I'm trying to pay that off over a period of time. So I am going to go with the second choice here. All right, A equals m, bracket 1 minus, bracket 1 plus I, bracket to the power of negative m all over I. Now, in order to use this formula, we need to verify our variables. So let's have a look here. I borrowed $350,000 for a period of 25 years at 6.5% per annum, compounding monthly. Now, I want to find the monthly repayment. So let's write down our key information. So A in this scenario is $350,000. I is going to be 6.5%, but we don't use 6.5% in an equation. We use its decimal version, so 0.065. Now, that is over a year, but because it's compounding monthly, I need to divide that by 12. And then we also know our time frame, which is n, which will be 25 years. But because our interest is compounding monthly, we need to convert our time in years into monthly periods. So we would multiply 25 by 12, which will give us 300 here. Now, the reason why I didn't simplify my interest is because personally, I like to deal with exact values, and I'll leave it as exact as possible for as long as possible. And because we're using a calculator, there's no reason we can't do that. So let's set up our equation. $350,000 is equal to m, bracket 1 minus 1 plus 0.065 over 12 to the power of negative 300 all over 0.065 on 12. Okay, now you could, if you choose to, guys, simplify the brackets here. You could choose to simplify that and then substitute it and manipulate it around in the equation, but I'm going to use it as it is and just put that into my calculator first. So let's have a look here. So I set up my fraction first, then we have 1 minus, open the bracket, now we're dealing with a 1 plus, and we've got another fraction. So I'm going to put 0.065 in the top, 12 in the bottom. I'm going to close my bracket. I'm going to raise that to the power of negative 300. Now be careful when using the negative sign, okay? It is a negative sign. It's not the subtraction sign, so don't push minus, all right? It's the negative sign you need to deal with. Okay, then I'm going to go down to another fraction, 0.065. Now, see how there was a bit of a delay there when I was pushing my buttons, guys? It's not just the software that I'm using. It is also your handheld calculator. So make sure when you're entering in the information, all the information is entered in correctly. All right, and that'll stop calculator errors. Okay, so I've got my section in now. Let's hit enter. And I get 148.1026,946. And it most probably keeps on going. So let's rewrite this then. I have $350,000 equals M times 148.102. And I'm going to put some dots after there. That's just going to signify that this decimal keeps on going. Okay, hopefully you realize at this stage in year 12 that in order to get M by itself, you need to divide it by 148.102. Well, technically you divide in both sides. So let's do that. Now, on my calculator, instead of typing all this information again, I can just type what I have on my left-hand side, so 350,000. And I'm going to divide that by my previous answer. So I'm just going to push up, select it, hit enter, and hit enter again. And you'll see there where we got 2363.23 if I choose to round it. So the solution for this is, what's the question? Determine the monthly repayment. Okay, so the monthly repayment, it's always good to write a sentence, especially for a 4-mark question, is $2,363.23.